Where does it show? Like,
Amazing. Twitter and X.
Twitter, no?
Gen morning, everyone. Let's see. We are live. Amazing. Well, hello from the GenLayer Offsite in Sitges. I hope I'm pronouncing it correct.
Yeah.
You are
Almost correct, yeah.
the native Spanish
Sitges.
speaker, Sitges.
Very-
Well, hello
very good
everyone.
pronunciation. Maybe you have a friend in Sitges, right?
Well, hello everyone. You already know me. My name is Tony, and we are doing our first live stream from our team offsite in Sitges, close to Barcelona. It's like a 40-minute drive to Barcelona. Having our planning week here, and yeah, as announced, we're gonna go through GenLayer. We have some of the hats here who are making this all happen. Edgar's, Edgar's has been in the live stream more often, or actually, he and I have been in the live stream. JM and Kirill have not been in the live stream. So, guys, thanks for taking the time. There's important meetings going on, but I think we have to inform our community what's going on. And yeah, today we're gonna talk about. Actually, before we talk about anything, I think it's important for you guys to introduce yourself and the role you have at Jaeger AI, and then we're gonna walk through all of the questions that we've planned. So maybe we start to the left
Okay.
with JM.
Sure. So, well, my name is Jose Maria, but people call me JM, which I think it's easier. And I'm one of the co-founders at Jaeger AI. I'm currently the CTO, so basically managing the tech teams to develop this protocol, no? Which is GenLayer. So that's basically what I'm doing.
Amazing. Kirill.
my name is Kirill. I'm consensus lead, or more or less, I'm the solidity master, leading the team with the solidity contract and everything that will be done by the consensus team regarding the solidity development.
Yes.
And hey everyone, I'm Edgars. I'm also a co-founder and the chief product officer. So I'm responsible for helping everybody design, everything down from the consensus level all the way up to user tools and developer tools and wallets, all kinds of things, making sure it all works together nicely and is easy to use and works great for everybody.
Cool, amazing. Well, as we're here, it's our second offsite actually. We had our first offsite also in Sitges. Maybe especially you two, JM and Edgars, as you are the co-founders, can tell us a little bit about the importance of team meetings. Like, what do you think? Is it even possible to have a fully remote, kind of decentralized team? Do we have to meet once in a while? I mean, obviously we have to, right? Because it was your decision to meet here. But maybe you can chime in on that a little bit.
I think it's important because it's always better, like the communication, like face to face. There are some things that cannot be probably replicated through a screen.
Yeah.
And then also like from a technical point of view, we can have like some discussions like more in depth, maybe with some blackboards and some pen and paper, which is also important. And also I think that's a good point.
Yeah. It's a different level of like efficiency in my especially for these team tasks, like once in a while meeting every few weeks or few months to kind of align on the overall strategy, and I also think like team chemistry in general.
Absolutely. I mean, I have been working in or doing remote companies basically since 2018. And I absolutely love the model. It lets us hire all kinds of gigabrains from all over the world, get the best talent from everywhere. And, it's also basically people, a lot of developers also like to have the freedom to work from wherever they are. And that's a very attractive model also for the best developers that we want in our team. At the same time, there are ways to make it work really well, but getting face-to-face time from time to time, it lets us have the best of both worlds. Everybody comes here, we can, as these guys said, discuss a lot of issues in depth, really rapid pace. Discussion just works better face-to-face, and then also everybody it's much easier to then go back and once you've seen the person you're writing to on Slack, you've seen their face, it's much harder to kind of be mean to them, right? You know who they are. You met them. It creates a different kind of vibe. Everybody believes knowing everybody else much better. It's a super valuable setup.
Not the back and forth, no, it's way easier because you don't have to like schedule a meeting or wait.
Exactly.
No,
You see
it's
somebody
like,
enjoying their lunch,
you.
you go like, I want to talk
Come
to you.
here.
And also the spirit is kind of lifted up afterwards and kind of motivate each other to continue pushing more.
Exactly. All these kind of discussions, about big picture things and where the protocol is going in many years, and everybody really gets inspired by all the great ideas that float around.
Definitely. Although, just for the record, no one was mean at GenLayer anyway, right?
Now they're going to be even less.
It's penalized. No?
Amazing, guys. Well, I would like to take this session to also discuss, especially since we have you three here that have such important roles in GenLayer and kind of making this what we're trying to do, the long-term vision that we have, which is this AI arbitration layer for AI agents, and kind of having these short-term milestones or goals of unlocking AI-powered dApps. We've talked about so many use cases. I mean, you, Edgars, have been all around the world at conferences. I think we have to align, like, why is it so hard, like in what we are doing and what we are building, why is it so hard to make it work? And why is our team perfectly set up, and what are the different components that go into that? If you could just give a high, macro level of what we are doing and what's happening.
The fundamental challenge with building something like GenLayer, or frankly any other blockchain, GenLayer has some unique aspects to it, but a lot of this applies to any blockchain, is that you have a lot of separate components and participants and actors in the system. So in terms of actors, you have all the validators and the users, and then the company building it, right? And different application developers that are deploying applications. So it's like a platform with many different participants that has to work together. And then more on the tech level itself, you have all these different components, from the consensus to the node to the GenVM to all the different tools and development tools in the studio, for example, different libraries and editor integration. So all these different tools, even if each one of them is not necessarily always complex, some of them are simpler. There's just a lot of them, which creates a fundamental challenge in how you organize the team and how do you make sure all these components that are built in parallel, they end up meeting at the right point in the middle, they all form a cohesive vision. And then of course you have the raw tech challenge. We're doing something novel that nobody has done before. In this case, this consensus between many different large language models, which introduces non-determinism. Well, it's kind of fundamentally harnessing non-determinism to achieve these goals. So there are completely novel technological challenges, and again, that we have to account for and make sure it's performant and accurate, and all the rewards and penalties, everything fits together. So while I think we're making very good progress and we're on track, and I'll tell you more about that. I think that's the core challenge of building something like this versus building maybe a centralized company where you control everything, where maybe your only interaction point are some users, where you have a lot more control here. All these different components with different properties that need to work together smoothly and seamlessly.
I mean, sometimes I'm like, I don't know how it is for you, Kirill, because you and I joined the company. These two are co-founders, right? For me, it's sometimes like, how did these guys came up with that idea? Is it like just, we met on a Friday for a beer, and then it's like, like,
not exactly like that, but yeah, I mean, yeah, we started like a while ago when all these ChatGPT and the first large language models started to be useful, and then we started thinking about how can we make those systems like more autonomous, more reliable. Then we came up with multi-agent systems, but in the end, after some a lot of discussion, we ended up thinking about a decentralized way of coordination, because it's probably one of the most efficient ways to make the system reliable, taking into account that most computation is not actually on on agents right now. So it's more on humans, and humans coordinate with money. So
Yeah. I mean, I know that you and Albert know each other. You knew each other from before, and then Albert had the connection to JM.
Yeah.
And then you kind of put your heads together, or like, how did this come together? That it's the three of you that worked on this.
Albert kind of joined JM's company. Basically, yes, I know Albert from back in 2018. So I worked with Albert on a number of big and smaller projects. So really like working with him. And then while we were between different projects, Albert joined JM at his company, and then a few months later he pulled me in as well because we were working on this AI stuff. It was really exciting. And yes, then we spent some time at JM Set exploring different directions, learning a lot more about how AI works, and then also using our background in crypto and all the stuff I learned at, for example, at Radix DLT about consensus mechanisms. And the third aspect, also all the kind of things I've learned through my career as an entrepreneur about the legal system and contracts and how that all fits together, and maybe the problems this system has, in terms of the cost and the huge amount of time it takes to resolve any contract dispute if you're going in front of a judge. All these kind of things combined together, and we landed on this new idea of this AI-based court system, AI-based legal system, where LLMs act as judges to resolve these contracts way faster, way cheaper than the traditional legal system.
I mean, you've kind of chimed into in a little bit, of the importance of having all these different components of GenLayer work together. Maybe you can describe the three components that you guys are working on. So we have GenVM, we have the consensus. Like, how does that all fit into together? Like, maybe if you want to start, Edgars, and then you guys can just add your level of expertise here.
Yes, what Tony is referring to are the three what we call core components, or core teams, I guess, as well. Namely, the consensus, which is a set of Solidity smart contracts that are going to run on the GenLayer chain on the zk rollup that we have. The GenVM, which is the execution environment. So this is similar to the EVM. This is where, for example, Solidity contracts are compiled and run on Ethereum and EVM-based systems. But the GenVM is the equivalent tool, the equivalent component for us. So this is where the Python-based intelligent contracts that can access internet, that can execute natural language instructions, they're written for and executed on the GenVM. And then finally, you have the node, which can ties both of these together. So the node is the component that, first of all, talks to the consensus contracts to basically see, first register as a validator, and then see as the transactions are coming in, what they have to do stuff. And then use the GenVM to execute the contract, produce some result, or produce a vote if they're in validator mode, and submit that back to the consensus contract. The consensus contracts ensure, who's the leader, who's the validator, who's penalized, who's rewarded, ensure all these rules are being followed, and all these three components working together basically form GenLayer. Yeah, maybe Kirill can tell us a bit more about what's happening in the consensus.
More or less, you described like in total. I always say that the consensus is kind of the heartbeat in center of all the GenLayer, following or enforcing all the rules that are established, and so the GenVM or all the validators can follow these rules through the consensus smart contracts that are deployed on the rollup.
Yeah, and then maybe just to give a bit more color on the GenVM and the node, because Edgars has explained it perfectly. So yeah, but yeah, essentially the GenVM is a custom execution environment that executes what we call intelligent contracts, which is Python-based contracts that are the ones that are executing those non-deterministic operations that enable the GenLayer protocol to access internet data and to process natural language. And yeah, so the GenVM is essentially this execution environment, which is WASM-based. And then the node, which is basically the host for the GenVM, is the interfacing part between the consensus and the actual execution. So basically, the node is listening to the consensus, and when it gets, okay, you are this validator, you will need to start executing this transaction, and then it launches the GenVM, it executes, if it's a leader produces leader receipt, and then like it follows like the whole transaction flow until it goes back to the consensus.
What's the difference? Like, I could just ask, why wouldn't you just build the whole thing on EVM? Like, what's the difference if you can just describe the major, differences between EVM, GenVM? Why do we need it at all? Like, I mean, obviously, we know it, but how would you describe the main difference?
Yeah, I would say main difference is that on EVM, the bytecodes and the low-level operations are not like able to execute non-deterministic stuff, so it's completely gated. And so in the way that we design the GenVM, we have different sub-virtual machines, what we call. One is fully deterministic, but then it can launch another, let's say, non-deterministic VM, but everything is like controlled in this execution flow. So that's probably the main reason of why we need a custom execution environment.
And there is no other blockchain that executes non-deterministic transactions.
I don't think so, and that's mainly
Not that we
because,
see.
yeah,
Ah,
I don't think so. Yeah, but
Yeah.
And also because of that, and because of the non-determinism of those transactions, that's why we need a very custom consensus algorithm, because like else how can a network of distributed validators agree on a, let's say, specific output, and what does that specific output actually mean? And yeah, that's why. Yeah.
Can you describe non-determinism in your own words?
Yeah, my own word is like technical description, very simple to understand, which is like, so if for the same input, so first, what does determinism actually mean? Which is like, if for the same input and either a different machine or a different time, you get the same output. No, for every time and machine, that would be a deterministic function or operation that you are executing. But if you change the time and or the machine and you get a different output for the same input, that will be a non-deterministic operation.
Easy way to think about it is some tasks are fully objective. Let's say, what is 2 + 2? It's 4. And I can ask anybody, and they'll hopefully tell me the same same answer, and we can agree on that. But
Flat earthers probably would not agree.
Not apply, but let's say an average should be fine. But there are some tasks that are not like that. For example, if I ask a million people to summarize an article, I'm going to get a million different summaries. None of those summaries is objectively correct or incorrect. Some of them are better or worse, but there's no objectively correct summary that I could point to. Yeah, this is the one summary. That's the real one. So how do you handle these kind of tasks? Or very similar, it's going to the internet. When I go to a web page, I see one version of the page. You go to the web page 5 minutes later, right? You see a different one, or maybe the website is even down, or things kind of change again. Or you look out the window and ask what the weather is again. Things change minute to minute. So how do you build a consensus mechanism that is able to handle these things, these tasks that are basically non-deterministic? They change depending on when and who does these tasks.
I'm just writing the download the POAP Home app. For those of you who have been watching more often, you know that you're going to get a POAP at the end of the session. So what you need for that is the POAP Home app. So I'm just going to put that here into the subtitle. Yeah, thanks, Edgars. And that's exactly what other blockchains. It's for us it's like this, but it depends on how you're looking. Yeah. So just so you know, we're sitting opposite of each other. So it's JM and me here, and Carol and Edgars there. That's why we're only using one microphone. One thing that's important and that I've seen people ask is, so we've talked about Python-based SDK, but you mentioned Solidity.
Yeah.
Can you explain the difference? Why Solidity? Like I'm confused now. I read Python-based SDK, and then this guy tells me consensus lead. Actually I'm the Solidity expert. So why do we need Solidity?
So I would say the main benefit is that we are able to interconnect with all the chains using a home rollup or a home blockchain, where we would put the whole consensus suite of smart contracts. These smart contracts are fully deterministic, because our rules will be fully deterministic, we would explain all the consensus protocol into this series of smart contracts. I don't know if I should reveal, but this is like work in progress, and so far we are in a very good shape regarding that. We are testing, and everything seems to work smoothly. I would also add that it's the only way that we can enforce atomic decisions or atomic rules without breaking the full consensus.
Mhm. And I have to add, so Kirill and Edgar's at our last team offsite, you did a 4.5-hour session on consensus, right? There was a lot of question marks. Although I knew the consensus before, it's seeing the whole flow of the consensus. It's just amazing. Like
It what it is. Right?
it's so many arrows and boxes, and then like maybe you can just high level, like we don't have to go into every detail, just high level describe of like how does it work. Okay, you submit the transaction, you've told us this today, but just high level, we know that there's appeals. You submit the transaction, how do we enable this non-determinism to happen on the blockchain?
So once the user submits transaction, then there is several roles that a validator can endure during a single transaction. So the first role is an activator. So some validator is randomly chosen by the consensus smart contracts to be an activator. An activator needs to activate a transaction. This is very important for the security of the whole transaction. The activator is electing a set of validators that not at least, one of them would be a leader, or a leader is another role that would execute the non-deterministic part of transaction, and based on this execution, it will propose the outcome of the deterministic part and the non-deterministic part. Once this outcome is registered in the consensus contract, the rest of the activated validators need to evaluate all the parts of this transaction or of this proposal. So the deterministic part, it's easy to be evaluated. The main issue is the non-deterministic part. So each of these validators vote based on the validation process. They can agree with the outcome of the proposal of the leader, or they can disagree. Or if they don't manage to come up with any agreement, they can just say, no, we give up, it's time out, we cannot validate this. Based on all the votes, the transaction is either accepted or it's denied or undetermined. After this checkpoint is done, there is a time window where the user or any other validator can appeal. During this time window, if no appeal arrives, the transaction is finalized with accepted or undetermined case. If there's an appeal, there are several outcomes that I won't.
Which we won't go into because
in detail, but it can reverse the whole process, and it will either resolve successfully or it will be resolved in another term of validating the proposal.
Okay, I know that we have only a few more minutes left, so that's why I would kindly ask you, Edgars, to kind of, we've talked about the different components, consensus, GenVM, like what it needs, like what are the next steps for us? Obviously, we are a blockchain, right? We are at a certain point in time, we're going to have a mainnet, right, where developers can build applications on. Maybe you can summarize, what the next step is for us and what this actually means, right? because of what we just said, right? Like, what does it mean to be the arbitration layer for AI agents? So kind of the next step, and what do you think what this leads to?
The next step, as many of you know already, that's coming very soon, is our testnet. Well, I would say even multiple testnets. I'll tell you a little bit more about that, but it's starting with the first testnet that's coming shortly. The goal of this is, well, there's a few different goals. One is for us to help onboard all these validators. So GenLayer, the consensus mechanism, requires many validators running different large language models that are able to aggregate their intelligence through this optimistic democracy consensus mechanism that Kirill described so well. So we need many of these validators. So one of the goals of the testnet is to enable all these validators to onboard, get familiar with the operations, really get set up, get ready for mainnet. The other goal is that we need to test, of course, all this system, make sure that it works, make sure that all these appeals and transactions and rewards and punishments and slashing and all these non-deterministic mechanisms, as well as, more simple stuff, just like scalability. GenLayer can do many transactions in parallel. We want to make sure that this works really well, and make sure the validators are really stable. They don't crash, they don't lose any data, they can recover if they do crash, which, that's just the reality of running a complex software system. You need to be able to recover from unexpected scenarios. So all these different components, verify the different contracts work. So that's another goal. So this is going to all kind of happen over multiple months as we build up to mainnet. We'll probably also have a secondary testnet that's more focused on developers. So everything I've said so far is more focused on the operations of the network itself. Of course, the third and very important goal for a testnet is also for our developers to be able to test kind of beta versions of their applications as they also get ready for the mainnet launch. So that on day 0, you have a wide set of novel applications that are running on GenLayer. So there's also going to be a testnet that's maybe more stable, where we don't run all these kind of tests, that's more focused on the quality of the answers and quality of the execution of the intelligent contracts, where you can test in real world performance, test your application. Also, test it with your users. So that's maybe relevant to many viewers on the call. So this is where you'll be able to start to beta test all the different applications that are running on GenLayer that all the developers are building.
Sorry, I just interrupt you here, because we have two questions that are kind of the same. What should we be looking forward in the testnet phase? Will there be a public testnet?
Yes, so all the testnets will be public. As I said, one of them is going to be more focused on the performance of the network itself. So you'll be able to, we'll be sharing a lot of information. So you'll be able to follow along all the different tests that we're running, the performance of the network. Some of them potentially you'll be able to participate in as well. And then as we get closer to the mainnet, that's where you'll transition more into, being able to try all the different applications that people are building on, the developers are building on. So yeah, just follow along. You'll get a ton of information as we kind of share it more and more, building up to mainnet.
And we have one question regarding the testnet. Which Q 2025 are we looking at? I think it's fair to say that we have news very soon.
Yes, we'll share when we can.
Very, very soon. As you see, we're all here working on making it happen. It's gonna happen soon, very soon, I would say. Okay. Yeah, thank you all, guys. Again, I know it's time sensitive. There's a lot of meetings going on downstairs. So I'm gonna let you leave. I know that you guys are all crucial for the next meeting. I'm gonna send the POAP secret key once again. And yeah, I would like to say thank you and simultaneously hello to all of you who tuned in. We have some community members: Caveman, Random, Bolo Engine, Vatan. Yeah, thanks guys for tuning in, for the support. You will hear from us very, very soon. Don't forget to mint your POAP, Jaeger minus Offsite, with the POAP home app. That's it for now. Thank you.
Thank you, Tony.
Thank you for taking
Thanks,
the time.
everyone.
See ya.
See you.
Bye-bye.
Bye.